Your support team just got a customer refund request. GPT 5.6 reads it, hallucinates a plausible answer from training data, and never actually checks the order database. That's the core problem. Static language models can't see the real world. On the left, GPT 5.6 is a one-shot generator. Feed it context, it processes forward in a single pass, out comes an answer. On the right, next-gen agent frameworks are decision makers. They pause mid-reasoning, fetch real data, adjust strategy, and resume thinking with facts in hand. Here's the concrete difference in a support scenario. Agent using only GPT 5.6 reads customer purchased item X, guesses whether to refund. Agent using a framework reads the same ticket, calls the database to fetch real purchase history, checks policy rules, verifies the item qualifies, then decides. Grounded, not guessing. The cost of hallucination in production isn't a meme, it's liability. One wrong refund decision, one missed fraud flag, one compliance violation. Next-gen frameworks eliminate this by grounding every decision in verified real data before surfacing an answer to the user. Memory is the second big shift. GPT 5.6 forgets you between messages. Every conversation starts blank. Next-gen frameworks maintain persistent state. They remember that user X prefers email, has VIP status, discussed a billing issue last month. No repetition, no who are you again. This persistent state isn't stored in the prompt, it's in a dedicated memory layer. Every interaction updates it. The agent can query this layer mid-reasoning to recall user preferences, past decisions, and context without reloading the entire chat history. The third difference is adaptive branching. When GPT 5.6 hits a failure, an API times out, it either hallucinates or crashes. A next-gen agent has built-in fallback logic. Try backup provider. If that fails, suggest alternatives. If critical, escalate gracefully. Old way, sequential manual handoffs, humans jumping in constantly, slow. New way, one agent orchestrates multi-step workflows end-to-end. Fetch account history, check inventory, process returns, escalate only if needed. Teams report 60% reduction in manual workload. Use case 1, customer support workflows. A ticket arrives requiring multiple steps, fetch account history, check inventory, potentially process a return, escalate only if policy exceptions arise. GPT 5.6 can't coordinate this. A framework orchestrates the whole flow as one coherent agent. Use case 2, autonomous data analysis at scale. You have terabytes of raw CSVs, logs, API dumps. You need outlier detection, forecasting, synthesized findings. A framework routes subsets to specialized models, fast classifiers for triage, vision models for images, numerical experts for predictions, then merges results into one coherent report. Use case 3, real-time fraud detection in payments. A transaction arrives. You have milliseconds. The agent compares it against user history, calls risk APIs, checks geolocation plausibility, decides approve or block using live data. This is happening now at companies processing billions monthly. So what's under the hood? GPT 5.6 is a black box. A next-gen agent is a layered system. Bottom, persistent memory. Next, reasoning layer where the LLM decides when to pause and call tools. Above that, the tool layer with APIs, databases, code executors. On top sits verification, fact-checking outputs, validating constraints, catching hallucinations before they reach users. Above that, orchestration, which decides which model handles which subtask, sequences steps, and branches based on real outcomes. The frameworks enabling this include LangGraph for explicit control flow, AutoGen for multi-agent teams, and CrewAI for role-based agent coordination. They're competing on orchestration intelligence, not just model size. Here's what a simple agent orchestration looks like in code. The agent defines a plan, loops through reasoning and tool calls, checks verification gates, and maintains state across turns. No hallucination pass-through. Every output is verified before surfacing. Let's compare model routing too. GPT 5.6 tries to do everything with one forward pass: image analysis, code debugging, data classification, all at once, often poorly. A framework automatically selects the right specialized model for each subtask: vision for images, code model for debugging, fast classifier for triage. Inside model routing, the agent thinks, this is a code debugging task, route to the specialized code model. For an image analysis task, route to vision. For claim classification, route to the fast classifier. Each specialist handles what it's optimized for, not forced to do everything. Processing an insurance claim using a framework: images of damage route to vision, text describing the incident routes to a language model, structured policy data routes to numerical reasoning. Results merge into a single recommendation with confidence scores and evidence trails. The travel assistant recommendation example shows the difference. Old system suggests a hotel without checking. New system generates a recommendation, then immediately verifies current availability, pricing, and reviews before saying I recommend X, catching if the hotel closed or price spiked. The verification and grounding layer works like a quality gate. All candidate outputs enter at the top. Fact-checking filters out hallucinations. Constraint validation removes policy violations. Only verified, grounded answers exit at the bottom to reach the user. The cost of not doing this verification? According to recent benchmarks, unverified LLM outputs carry 15 to 40% hallucination rates depending on the domain. With verification, that drops below 1% in production systems. Now the honest part, this is more complex than a single model call. You need infrastructure for state management, reliable tool execution, API latency handling, and debugging when agents go off the rails. If your problem is simple enough for a prompt and GPT 5.6, use that. But here's where next-gen frameworks become mandatory: decisions grounded in real data, multi-step reasoning loops, fallback strategies, and memory across conversations. These aren't optional bells and whistles. They're the only way to ship production-grade agents that don't hallucinate and actually adapt. The industry has moved past just prompt the big model better. The next era is orchestration, combining specialized models, verifying outputs, maintaining state, adapting to real outcomes, and building systems that don't just talk, they act, learn, and correct course.